Linear inequalities. In our previous classes, we have studied linear equations. That is, when there are two expressions which are separated by an equal to symbol, right? So now in this class, we will be studying about linear inequalities or inequations. And what do you mean by these inequations? And how is it different from what we have studied, that is equation? So let's look at what is a linear inequality. So inequality symbols are mainly what? Less than or greater than or equal to or less than or equal to. For example, if I write 2 less than 5, that is an inequation. It is not an equation, it is what? An inequality. Another example is minus 3 less than negative 6. That is also an inequation. X less than or equal to 4 is also an inequality. Here you can see that there is less than and equal to also. But since there is a less than, you can call this as an inequation. And if it was only x is equal to 4, what you will call? You will call this as an equation, and which we have studied in our previous classes. And y greater than or equal to 0 is also an inequation. So these are different examples of inequalities that we will be looking in this session. So now let's look at the interpretations of the signs of inequality. And the first one is less than. That is a less than b, which is denoted by the less than symbol we always use. The next one is greater than, a greater than b. And the next one is equal to, which is a equal to b. Then less than or equal to, and also greater than or equal to. So these are the different signs that we are using in inequations. Now let's look at the different types of linear inequalities. And the first one is numerical or variable. And then we have less than or equal to. And we have x or x square. What is this x or x square? It is either linear inequality or quadratic inequality. So first we can look at what is numerical or the variable inequality. Numerical inequality is nothing but, example, if we say 3 less than 5, that is a numerical inequality because it contains only numerals. And the next one is what? The literal inequality, which contains variables. Suppose if I say x greater than y or x less than or equal to y square, these are what? Literal inequalities because it contains variables. Now moving on to the next one is the linear or the quadratic inequalities. So if we have degree only 1, then we can call it as a linear inequality. And if you have the degree 2 in that inequality, we simply call it as the quadratic inequality. For example, if I say x greater than 10, that is a linear inequality. Suppose if I say x square greater than y plus 5, that is a quadratic inequality because it's containing a degree how much? 2 there. Next one is the strict or the slack inequality. Strict inequality will be containing only less than or greater than. It won't be containing less than or equal to or greater than or equal to. It will only contain less than or greater. Suppose if I say x less than 5, that is a strict inequality. Or x greater than 10, that is a strict inequality. And the next one is what? The slack inequality, where it can contain less than or equal to or greater than or equal to. Suppose if I say y greater than or equal to 15, y less than or equal to minus 3, these are examples of slack inequality. So now we have studied different types of inequalities, right? Now let's move on to one inequality here, that is x less than or equal to 4. So if I say this inequality, I can say x is equal to 3 is a solution of this above inequality. Why? Because if I take the real number line and mark this 4 here, that is x is equal to 4. So if I mark x is equal to 4, that is just a point. If I mark x less than or equal to 4, what? What does it mean? It means that it can take any number which is less than or equal to 4. So this inequality can have a solution what? X is equal to 3? Yes, because that 3 is less than or equal to 4, or it is satisfying the condition given here in the inequality. So x is equal to 3 is a solution of this above inequality. Suppose if I take x less than or equal to 4, the set of all values less than or equal to 4 is called as what? The solution set of this given inequality. So x is equal to 3, 2, 0, minus 5, these are all what? The solution set of this given inequality. Now moving on to the next one, where we are going to find out the rules of solving an inequality. Suppose if I take x greater than 6 and if I add 3 throughout this inequality, I will be getting x plus 3 greater than 6 plus 3. So what did I do here? I added 3 on both sides of the inequality and I got x plus 3 greater than 6 plus 3, which is nothing but x plus 3 greater than 9. And the same goes for subtraction. If I subtract 2 throughout this inequality, that is x greater than 6, I'll be getting x minus 2 greater than 6 minus 2. And that is nothing but x minus 2 greater than 4. So these are the first two rules that we will be following in solving inequalities. That is, if I add or subtract a positive number or a negative number on both sides of the inequality, the sign does not change. So remember that the sign, that is, if here it is greater than, if I subtract or add also, it will be greater than. So here again greater than, and when I subtract it also, again that is greater than. Now moving on to the next one, again x greater than 6. The next rule, here if I multiply on both sides by how much? 3. So if I multiply x greater than 6 by 3, I will be getting x into 3 greater than, still it is greater than. The sign did not change, it is still greater than, and it is greater than what? 6 into 3. So what is that? X into 3, 3x greater than 18. So again, if I take this linear inequality and multiply by a positive number, remember, I'm multiplying by what? A positive number. The sign does not change. It remains greater than itself. And if I divide both sides by 2 again I'm dividing by what? A positive number. I'll be getting x by 2. Here I'll be getting x by 2 greater than 6 by 2, which is nothing but x by 2 greater than 3. So if I divide both sides by 2, I'll be getting x by 2 greater than 6 by 2, which is nothing but x by 2 greater than how much? 3. So these are the next two rules while solving a linear inequation. On the next one again, x greater than 6. Again I'm taking the same inequality and I'm multiplying both the sides by how much? Negative 2. So listen here, I'm multiplying here by a negative number. So when I multiply by a negative number, what happens? X into minus 2, then on the right side I have 6 into minus 2 or negative 2. But what happens is the sign which is greater than here will become what? A less than. That is, the sign will change of the inequality. So remember, when you are multiplying by a negative number, the greater than sign will be changing into what? A less than sign. So x into minus 2 and 6 into minus 2. But how will you write the final inequation? You can write it as minus 2x less than negative 12. So that is the final inequation after multiplying by a negative number. The next one is when you divide both sides by minus 3. We are dividing by a negative number. So again, when you're dividing by a negative number, x divided by minus 3 and the right side is 6 divided by minus 3. And what is x divided by minus 3? It is minus x by 3. 6 divided by minus 3 is how much? Minus 2. But what will happen? This greater than sign should be changing into a less than sign. So again, you will be getting minus x by 3 less than negative 2. So these are the rules that we must follow while solving a linear inequation. So consider an example. Solve the linear inequality, that is x plus 5 greater than 0. So when x plus 5 is greater than 0, when you have something like that, I need to remove this 5 from the left side. So to remove that 5 from the left side, what should I do? I should subtract 5 from both sides of the inequation, right? So when I subtract 5 from both sides of the inequation, I'll be getting something like this, that is x plus 5 minus 5 greater than 0 minus 5. So here I'm using a rule that we studied. I'm subtracting a number here. When I subtract a number here, what does not change? The linear inequation sign does not change. So it is still greater than here. So x plus 5 minus 5 greater than 0 minus 5. And you finally get x greater than minus 5. So that is the final solution of this linear inequality. Moving on to another linear inequality, that is 2x minus 3 less than or equal to 1. So here I have 2x minus 3, that is along with x there is a 2 multiplied and there is a 3 subtracted also on the left side. So it is less than or equal to 1, right? Now I need to first remove this negative 3. So to remove this negative 3, what should I do? I should be adding a 3 on both sides. So the first thing is I'm adding a 3 on both sides. So when I add a 3, I'll be getting 2x minus 3 plus 3 less than or equal to 1 plus 3. And the next step, you will be getting 2x on the left side and 1 plus 3 will be what? 4. So 2x less than or equal to 4 is the next inequation that we get. Is that the solution? No, there is still a 2 along with x. I need to remove it. So to remove that 2x from to remove the 2 from the 2x, I need to divide the whole inequation with what? 2. So I'm dividing both sides by 2. 2x will become what? X, and 4 will become 2. But it is still less than or equal to. Does the sign change? Does not change, because I'm dividing by a positive number. So when I'm dividing by a positive number, the inequation sign does not change. So x less than or equal to 2 is the final solution of this linear inequation. Now, how to represent these inequations in a number line? So let's look at the first one, that is, if an example it is given as x less than 2. X less than 2 means what? X can take any number which is lesser than 2, or in a number line, if I say x can take any number which is of the left of 2. That is, from 2 to what? Negative infinity. So the number line will represent x less than 2, the number line will represent minus infinity to 2. And can it take 2? It cannot take 2. Why? Because it is less than. So it cannot take 2. So I'm just putting a circle, I'm not shading it. So listen carefully, I'm just putting a circle over 2, I'm not at all shading that circle there. And when it is x greater than 2, that greater than 2 means it can take any number which is greater than 2 on the number line. How can we denote it? From 2 to positive infinity. So from 2 to positive infinity, if I draw in the number line like this, I can see that the 2 is just circled. It is not shaded, because here also it is greater than. It is not greater than or equal to. It is not taking the 2. So from 2 to everything on the right side till infinity. So 2 to infinity will be the solution for what? X greater than 2. And now comes the next one, that is x greater than or equal to 2. So from the previous one, x greater than 2, you can see we have just circled. In x greater than or equal to 2, what we did? We are taking the same area, that is from 2 to infinity, the right side of 2, everything on the right side. But we are shading that circle because we are taking 2 as well. And the next one, x less than or equal to 2. From the less than 2, we just circled 2. And here in less than or equal to, what we are doing is we are circling the 2 as well as we are shading that entire circle to minus infinity. So I hope you have understood how do we represent inequations in a number line. Now let's look at some more representations on the number line, which starts with minus 2 less than x less than 1. So here the x is in the middle and you have two sides, that is, one is minus 2 less than x, then till 1. So is the inequation taking either minus 2 or 1? No, it is not taking any of this. So I'm circling minus 2 and 1. I'm just circling. I'm not shading at all. I'm just circling. And everything in between minus 2 and 1 will fall under this inequality. And the next one is minus 2 less than or equal to x less than or equal to 1. So here what happens is the same area I'm shading, but along with that I have to shade minus 2 as well as what? 1. Because it is taking both negative 2 and 1. And the next one is minus 2 less than x less than or equal to 1. So here one side is having less than or equal to, but the other side is having only less than. So what happens is minus 2 and 1 both are circled, but here in the one part you have a less than or equal to. So what will I do? I'll just shade this area, and whatever comes in between negative 2 and 1, including 1, will be taken under this inequation. And the last one, minus 2 less than or equal to x less than 1. So here what happens is minus 2 is taken, yes, but 1 is not taken. So everything in between minus 2 and 1, including negative 2. And now look at the interval notations also. When it is both less than, what we do is we put an open interval, that is open interval negative to 1. And when it is both less than or equal to, we put a closed interval, that is minus 2, closed interval minus 2, 1. And when one side is closed, how will we represent? Open minus 2 and closed at 1. And here the next one is, it is greater than or equal to in the beginning, so you will be taking closed minus 2 and open at 1. So this is how we represent these inequations on the number line. And there's a next question, that is solve for x, that is x by 2 minus 9 greater than 5. I have to solve this inequality. To solve this inequality, first I need to take this minus 9 out, right? So to solve that, I have to remove this minus 9. So I just take it to the right side, or I add 9 to both sides. Either of these can be possible. So when I add 9, or if I take this minus 9 to the right side, it becomes x by 2 greater than 5 plus 9. that is x by 2 greater than 14. And this divided by 2 should be taken to the right side and it will become a multiplication, the same as how we do in an equation, right? So x by 2 greater than 14 will now be written as what? X greater than 14 into 2, that is 28. So this gives us the final solution of this inequation, that is x by 2 minus 9 greater than 5. The next question is solve for a, which is 3x plus 8 greater than 2, where a is equal to x, which is an integer. So to solve this again, 3x plus 8 greater than 2. Yes, so to take the 8 to the right side, you will be getting 3x greater than 2 minus 8, that will be negative 6. Yes. And now I have to take this 3 to the right side. I will be getting minus 6 by 3, right? So that is x greater than negative 2. So now we got x greater than negative 2. And they have said that x belongs to what? An integer. In the question, they are saying particularly that x belongs to an integer. X is an integer. So when x is an integer, when x is greater than negative 2, it can take all the integers which are greater than negative 2. That includes negative 1, 0, 1, 2, and after that, all the integers can be taken according to this inequation. So now we have studied linear inequalities. What is the definition of a linear inequality, and also how to solve the linear inequality using the different rules also that we have studied. So now there is a question, given that x, y, and b are real numbers, and x greater than y, b greater than 0, then what about x by b dash y by b? So what will you fill here this gap with? So you can see that b is greater than 0, that is, b is what? A positive number. When you divide x and y by a positive number, x is already greater than y. What happens? We have already studied that in this session. So just give a look back and try to fill this gap. I hope you have understood what all we have learned in this session. Let's have a quick recap of what all we have learned.
Manorama Horizon. Learning made simple.